Hello, everyone. Thank you for joining this seminar series organized by the Empathic Computing Laboratory. I'm your host, Aladdin, and our guest speaker for today is Associate Professor Michael Nebeling, who is currently an Associate Professor at the University of Michigan. His research interests are in augmented reality, extended reality, and um, democratizing extended reality. He has done a lot of research since 2010, is that correct? And
I would say 16 is really AR/VR since 16.
16.
Yeah.
And his title of the title of his talk is Extended Reality for Everybody. The talk will be roughly about an hour and followed by a brief question and answer session. Michael, welcome. Over to
Well,
you.
thank you. Thank you very much. How cool would it have been to really go and visit you physically? But it's great to meet you this way. I'll start sharing my screen, and don't worry, I'll explain about the exit and all that in a second. So yeah, I call the talk Extended Reality for Everybody because it is really uh, a mission and my theme over the past few years. I wanted to enable more people to be able to design XR, so AR or VR experiences. And I'm aware, to some extent, I'm aware who I'm presenting to. So, but I did, um, I did just. My goal was for this talk to go over a few themes of my work and share those lessons learned. I have not given these kinds of talks so many before. It's usually about a specific project, but here I try to really reflect on my work over the past 5 years in Michigan. So I'm an assistant professor still. So this is me. So as you, I'm originally from Germany, and that's where I grew up. But I did study in Australia, actually at Monash University in Melbourne. And I did my PhD at ETH Zurich, so that is in computer science. And but during the time, I was really interested in adaptive interfaces, and I learned a lot about context awareness, and also my PhD was in that. And then over the last 5 years, I've really found a passion for AR and VR. So I'm in many ways not as experienced as many of you are in this space. Very passionate though, learning a lot all the time. So currently I lead a lab. It's called the Interaction Lab, the Information Interaction Lab. And it kind of from the outside looks like this. Inside, it's not super big. We have all kinds of AR, VR displays and have a lot of fun in there. But since COVID, this is my lab. So I just took a screenshot of a photo of what it looked like during Kai for me, where I was, is actually where I am right now. So you can see a little bit, imagine me sitting in front of this desk and I have the light and microphone and various cameras. And I usually teach using VR. So there's always a VR headset available. But I'm not going to do that today. I keep it very straightforward and basic. Yeah, so one thing I did, and I wanted to share this a little bit with you, is an online course. It's been a year of work. I'll just like it built a little bit, but it's been a year of work. It's actually 3 online courses, xrmooc.com, and you can find out more information about that. I think of it as it's a learning resource. It helps a lot of students here at Michigan want to learn more about AR, VR. And so these 3 courses are really designed to be an intro, very focused on XR design, which was a lot of the prototyping. Mark and I gave a prototyping course at Kai this year. It was a lot of fun working with Mark and getting to see his experience. And it was really exciting, actually. And I also have a course that I think needs a little bit more work because I'm not sitting down and spending sufficient time in Unity on XR development. So it's 3 courses that a lot of my research and some of the work I present today as well went into some of these blocks. I've worked on a lot of prototyping techniques over the last few years. And when I say I used AR, VR for teaching, one of the things I like to do is use immersive authoring. I'm probably not as skilled as many people that do this really for 3D modeling, but for teaching, and it's actually been, I will come back to this way of presenting and teaching to you. This is Tilt Brush using mixed reality capture, a software called Live. I'm standing in front of a green screen, and this is going to be post-processed by a media team. And it was a professional film team especially involved. This is also one of the lectures called What is XR as part of my MOOC, and I explain essentially how 3D sketching works here and how it can be used for prototyping, but also it is an interesting way for viewers to experience it, because I'm not sure what it's like for you, but despite all our efforts and we are well equipped in our research labs, but doing AR VR in the classroom is actually still a major challenge, especially if you teach AR VR courses. Access to these devices is still difficult. So why not explore means like mixed reality capture to bring AR VR experiences to students who may not have access to VR? And so I'm always exploring these technologies and how to build them into my own teaching. So here's the structure of my talk, as far as you can call it a structure. So I said, I mean, I've been very active in the human-computer interaction area. So CHI is my main conference. I've been quite busy over the last few years writing increasing papers about AR, VR. And so I was thinking about what did I actually do and learn over the last few years. And so I'll tell you about each of these themes in a bit more detail. So I was, and there's actually one of my students from my lab, I invited Shweta also here on camera, at least I can see her. So studying 4 themes. One is around really studying misconceptions. What do people actually mean when they say extended reality or mixed reality in particular? It created a lot of confusion. So we explored that. We were studying some of the thresholds, like what is it, how difficult is it actually still, despite all the tools that we have available today, and many of them are actually quite usable, you would say. What are the key barriers to entry still? How can we actually study user behaviors in mixed reality? Are there advantages to using these AR VR devices for capture and tracking? Could we visualize that data? So I'm not the only one exploring this, but these are some of the projects from the first theme. In the second theme, I was really looking at how to empower more design participants. It's been very important to me, and I'll show you examples of this work. How do we enable non-programmers to, I work with a lot of user experience design students, interaction design students. They do a lot of paper prototyping, and then what do you do after paper prototyping? And so I really created a suite of tools. I'll walk you through some of them. I won't go over each of them, but I try to classify my own work and where it appeared if you're interested in some of that. So a lot of people think all Mica does is designing and publishing prototyping tools. It's been quite a lot of fun, but it's not the only thing I'm doing. Studying, and there has been some overlap or at least some intersections with Mark's work, who obviously publishes like 100 times the scale of what I'm doing, but on the use of 360 and creating meetings and making meetings more immersive. And so I've done a lot of work in that space, and I mean a lot, relatively speaking, for me. And I would characterize this work as enabling and studying collaborative experiences. And I actually think that we will see a lot more in this space over the next few years. We've definitely seen a lot of projects already. So I'll tell you a little bit about that. And finally, and remember the theme, the overarching theme of my work is empowering more people to become design participants. So if we have this extended reality for everybody, where everybody is a player, how do we, it's not like everybody does a good job when it comes to AR VR design. There's a lot of bad experiences out there, potentially unsafe. And so I was thinking about a more recent stream of my work, which is not published yet so much, is creating examples and tools that promote inclusive, and I mean from an accessibility standpoint to some extent, but also from an equity standpoint. Not everybody has access to AR/VR technology. So I'll come back to this introductory video I just showed you and show you my latest project on XR Studio, and then tell you a little bit more about how I want to take this work further to promoting safe design. And so with the recent students in my lab, I'm looking at privacy and security, which I've so far always excluded. I was said, this is for other people to study. I'm not a privacy security researcher, but when you do AR, VR, and you want to create experiences, for example, for educational settings, studying and supporting accessibility as well as privacy is actually a key thing. So I will go deeper into these directions in the next few years. So what I'll do now is actually I'll just go into each of these, show you some examples. Hopefully, maybe you'll like some of the things you see, and maybe there will be some takeaways. And at any time, I mean, we can have a 30-minute discussion afterwards, or this is my plan. I can throw out some things if you have a bit of discussion. Feel free to interrupt me. So what is mixed reality? Is it interesting? It's actually an interesting question, and a lot of you might point students and colleagues to definitions like Paul Milgram's mixed reality spectrum or virtual reality continuum. But turns out, we did a relatively detailed literature review in the HCI literature. So we did include ISMAR and some of those conferences, but our focus was really on CHI, WIST. And the term mixed reality appeared more and more often, and it was actually used inconsistently in the literature. And so we identified 6 working definitions. I'll just spell them out here. So 6 working definitions. And the reality-virtual reality continuum is one, but it is not adopted by a lot of practitioners. We did expert interviews as well. We talked to people working in the AR/VR space, including Google and Mozilla and some of the places that you would expect. And for a lot of people, it's just a synonym for augmented reality. It can be used interchangeably, not being aware of the reality-virtual reality continuum. Many of them think it's some kind of combination of AR, VR. It's like where things blend. You can see yourself. The funniest explanations of what the mixed reality is. Thanks to movements like Microsoft at the time and Intel, it is a stronger version of augmented reality. It's a new thing. It was in 2016 and 17. Windows mixed reality was created as a platform. It was a new thing. Many of them just think it's a type of collaboration. A lot of people think that mixed reality means you can interact with content suddenly. AR is just looking at things. Mixed reality is when you can start touching things. And finally, an alignment of environments. Just this blending, and maybe they think of some of the experiences I showed in the original in the video earlier. You see this person inside this virtual environment, and they are perfectly aligned, for which we need to calibrate. So it is interesting. And my main thing is, and when I talked, and I'm involved in a lot of discussion here at Michigan, it's a big public university, so who really wants to be a leader in AR VR. And whenever today I had a meeting with 12 deans, it was very interesting. I hear a lot of uncertainty about some of these terms. Is it virtual reality or augmented reality, or call it whatever? And so I think it's very important that we are clear about the terms. And so so what we did on the research side is we really did a significant literature review. We were tracing back some of the latest work to some of the early papers, coming back to the 1994 Milgram and Krishinos, and tracing back. And so Mark definitely has played a role in many of these, and we may not even show all of it here, but we were trying to plot some of these, some of this work, and you may see some familiar names here from Tam and others. And it's interesting. It's kind of like almost 2 schools. Those who are academically rooted, and there's a lot of pointers going back to Milgram and Kishino. And then somehow magically, Microsoft and HoloLens created like their own thread, and people are starting to lose the history a little bit. It's interesting. If we continue plotting this, there might be people thinking that Microsoft invented mixed reality. So it was interesting. I said we did letter review and we did expert interviews. This is it is a Chi, an HCI paper. So we wanted to do a combination of what we can find in literature. Here are the 6 definitions. How many of these we could find, and when we analyzed the literature and did some coding. Reviewed. It's not super in-depth. Mark has done much more extensive literature surveys. But our sampling of the more focused HCI literature, the idea of the continuum, which probably is the one and only truth for many of you, I'm not sure, is only a third of the literature. And many actually don't know really how to define it or have one of these more, I mean, in my opinion, more confusing definitions. And so the long story short is also when it comes to the experts, and we had definitely experts from academia, 5 and 5 from industry, and those in industry actually had a lot of academic training, so PhDs. The original definition doesn't get applied a lot, so it doesn't get carried forward by experts too much. So original definition, I mean, that was also just based on a lot of work. So it's interesting. And so as part of our work, we were trying to think through what could be a better framework to think through some of the dimensions to characterize existing mixed reality experiences. And so I'm not going to go over each of these, but we were quite inclusive and have that in more detail in the paper that is called What is Mixed Reality? And our framework is being adopted recently in some of the a lot of paper. So to be honest, the What is Mixed Reality paper, and as I said, I am quite active in the HCI area. It is going to be my most cited paper because it's already my second most cited paper. Now, don't have too many citations, you might say. But it is interesting. It seems like a lot of people were looking for, it's one of those papers that when you write it, what is mixed reality? Or let me find this citation. But what we find sad is that most people just cite it so that they can call their thing mixed reality, but they don't actually really apply our framework to think through the dimensions. And we have, for this framework, we have 7 dimensions. For each of these dimensions, we have values based on the literature to really help people classify their work better. But while the paper has a lot of citations, it doesn't actually, I mean, still less than 100, but almost 100. It doesn't actually get used in the way that we want it to be used. It's also interesting. Sometimes I struggle with the research that we do and how it's being used. I want to go to the next subtopic in this, studying misconceptions, thresholds, and user behavior. Key barriers to entry. What many of you are probably very experienced in AR/VR design, and I'm opening the chat here so that I don't miss any questions. Right. Okay, Mark's gone. Okay, have fun, Mark. So yeah, Microsoft was doing their own thing. That's great. So on the key barriers to entry, I wonder if you think about, okay, so let's say, just for a second, you forget everything you know about AR/VR and you imagine you're a new student and you want to do your first AR/VR project. What do you think is the most difficult thing for you to get started in this space? What are the key barriers to entry? And so again, an HCI study, and I don't know how many of you are active in human-computer interaction, but this is definitely my field. We did a study with 21 novice AR/VR designers. They fell into 3 groups. Some of them were actually trained professional interaction or user experience designers or programmers. Some of them were more like hobbyists and really just wanted to try to do things. And so for this range of people and there will be more of those hobbyists, let's say, or maybe end user programmers if you want. What is the scale? What are the key barriers to entry? So in our paper, which was published last year, I don't exactly copy paste what's in the paper, but I'll tell you my interpretation of our results. So the starting point is like, where do you actually get started? Like, what is it? Is it Unity? Hang on, I hear Unity all the time. Is that the tool I need to learn? That seems like easy. And then, oh my God. It is actually that many of us don't actually have many of us have a training in 2D design, for example, for web and for mobile. And now how do we translate that? So this making this jump from 2D to 3D is an issue. Finding good examples, my favorite issue. And obviously we all think of our research as maybe good examples, but in many ways, we don't actually have a lot of good examples yet. And the companies are really after case studies. All they want, and actually that is funded, in my opinion, or my experience, the research funding works better if you produce a case study than if you actually try to improve AR/VR itself, which is actually my area. I'll study right now how to make it better in some sense. But in many ways, we just want to produce some case studies of whether they're good or not, as long as you use our HoloLens. Too many tools. What do you think? I mean, maybe I'm curious what kinds of tools you use, and if you are on the more practitioner side. I'm not super fit with Unity. Many of my students are better with Unity, and Unreal is something that I'm also not that proficient with, but I do a lot of WebXR prototyping, and that was my transition into the AR/VR space. I was coming from web engineering background. Actually, who do we design for? Who do we reach? How does it even work? What do you mean marker-based versus markerless? What does that make a difference? Yeah. So, and then on the VR side, I mean, it used to be we had to distinguish street off, inside out, outside in. I mean, in some sense, we do get a little bit more alignment now, but also at the cost of removing cheaper, more affordable VR experiences like Cardboard, Google Daydream, Oculus Go. I'm probably not the first to tell you that those are all dead now, but if I am, I'm very sorry. Google in particular has had this idea that we put everything on the Google Graveyard. You can Google this website, the Google Graveyard, and Poly, Blocks, Google Expeditions. A lot of the tools to be used in teaching actually are dead now. Tiltbrush was announced as this open source thing, but what it actually means is they just stopped working on it. At least they made it available to the community, and it was very exciting. Anyway, finally, I think, and this is actually the biggest concern to me. Once I've created something, I don't actually know whether it's good, and I don't know exactly how to assess it. What are good metrics? And so it's very interesting to us in AR/VR, bringing AR/VR into the classroom to actually improve the learning experience. And there are two things to it. One is studying learning, which is actually a discipline in its own. And then studying the AR/VR specific aspects. So what are actually the new metrics we need to look at? And so I've been thinking a lot about this. So the jump from 2D to 3D, I mean, to many of you it's clear, but maybe this is how I think about when I create a prototype. I often start on paper, and I still promote paper a lot in my work. You'll see some examples. And making this jump to 3D is obviously not just adding another axis. It's actually thinking the perception works different, scale works different. It's not trivial, and it means that when your goal is to create an AR or VR experience, and actually I think the way I plotted it here, and I'm not sure whether you agree, but it could make a case for creating an AR experience as harder, one that truly makes use of the environment. Anyway, so making this jump is hard, and the tools that we have maybe get you. Even this, if you zoom in, VR is actually very big and very multifaceted. So how good is actually the VR experience? Is it enough that it's on your head, or is it, or in AR, is it enough that you see a 3D model in the room, or is it should it be more pronounced, better experience? I'll quickly give a rant on XR tools. I've studied XR tools a lot. I give a lot of recommendations. It's a massive tool landscape. It's hard to get started. It's hard to keep track for experienced people. So the design process there's no single project that has used the same tool chain for me. And I haven't done as many as people would do in industry, I'm sure. Every AR/VR app requires a unique tool chain. Prototyping tools are too limited for most apps. You cannot actually do it unless you go into Unity or whatnot in the end. Development tools are actually out of reach for a lot of designers. There are some people who have preferences for Unreal over Unity, but still both have a high learning curve. There are significant gaps between and within the tools. So jumping between tools, doing revisions, from a prototyping tool integration with Unity. So we've looked, for example, Mark and I, we've looked at Maquette and how well does it integrate with Unity for our prototyping workshop. And once you're in Unity, what if I want to make revisions in Maquette? What does that mean? Do I lose it in Unity? And yes, and so it really makes design iterations tricky and expensive. And so I've classified the tools a little bit, and it just helped me to think about the space. And won't go over this taxonomy, but it's an ISMAR workshop paper. And what is interesting to me is actually how 3D modeling and authoring is really living in its own world. It's not very well integrated. I mean, you can do some editing in Unity and Unreal, but it's really its own tool chain. It has really high skill set requirements if you want to do it well. Immersive authoring is quite promising, but like really at best, while you are in AR VR, and so it increases the level of fidelity, you can actually, with most authoring tools, immersive authoring tools, including some of those in research, you can't actually do a lot. And so a lot of the tools that I was working on, I wish they were here. Very high fidelity and almost no skill required. But I put a question mark because I think it's a big claim, and like I'm actually not sure. I think it's easier than A-frame. I'll show you some of these tools next, because I've worked a lot on those. So I'll actually jump into those tools. I would have something on mixed reality analytics. I come back to that if that is of interest. I want to continue going into some of the tools. So when it comes to prototyping, so I played some of the tools that I've worked on. So one aspect that I was interested in was really enabling rapid transition from paper into AR and VR. So here I show a few of the steps required to create a mobile AR app that is essentially IKEA Place, and IKEA Place allows you to place virtual furniture in your room. And they claim in their video it's 98% accurate. The size, it'll fit, it'll fit in your room if you buy this bed. And so we were thinking about how would you prototype it and what are good techniques to do it. And since I'm not very good at 3D modeling, but it's actually almost a requirement for some of the experience we want to create, we worked a lot with Play-Doh. So in my paper on Proto-AR, we explored what's a good workflow to bring 3D modeling in it and make it easy to transition from paper into a mobile app. And we developed a technique that is not super advanced, but it works on all smartphones, which is you capture a virtual model, you capture a Play-Doh model from different angles. So you do kind of like a 360, it creates all these perspective images. And then when you replay it, you would present, you don't do photogrammetry or any advanced thing. You just choose the corresponding perspective frame and you blend them as the user moves around them. And so you can create an experience that allows people to preview this. And this was, it was interesting at a time when we didn't have, it was pre-AR Core AR Kit. And we implemented marker-based and then also now markerless. It is a good, you could say now, okay, I can do this with my iPad now, I have a LiDAR. We didn't have that at the time. Anyway, I would probably update the technique a little bit. But it's interesting that we can do this much more advanced now. I looked at really the value of paper, and in a lot of my interaction design, I value paper a lot. And I'll show you what I think prototyping for tiny fingers, magnetic paper would mean today. And a lot of the tools, I'll show you a few tools now where we use the idea of Wizard of Oz, or the idea of a computer, a human actually animating and manipulating objects in a way that the user may not always know this. And so you can simulate interactivity. And so really designing around the user has been interesting for me. How do we do it? Why we do it on paper? And so this 360 grid is something I've studied, and it's been coming up a lot in the practitioner community. So what can we do with it? We've done work on how can you compose more complex scenes? How can you build essentially from layers? What are good ways to structure these layers? And then how can we actually experience them from a first-person perspective. And I'll play, if you create these intersecting spheres at different scale around the user, you can actually achieve some kind of parallax. You can have these butterflies appear closer, the mountains somewhere in the midground, and the trees in the midground, and the mountains in the background. And so just using a 360 paper template, you're probably very familiar with this. A lot of people who see this for the first time think it's cool. You can also create rooms this way. It's a bit more creative use, I think. So if I actually, again, sketch in layers, but then I take one of the spheres and move it outside, I can create a star track. I'll show you the star track. This is a VR prototype created in a few hours. And it is, we experience it now in AR. So we're going to walk through this holodeck. This is, or actually the bridge, we're on the Star Trek Next Generation bridge. And so we were like walking into the observation room, which is one of the sketches that we moved out. It's a sphere, and then we cut some things out of paper. And so you can see the real world. It's not super interesting because I'm in this kind of like a weird room. And then we have the screen cut out. So basically we are on Star Trek, the Next Generation, and we just landed our little starship inside this building. And in any case, I thought it's cool to make paper prototypes interactive. And I want to show you one. We can do it with cutouts, paper cutouts. I mean, then you can experience it this way. So I'll show you an aspect where we're going to manipulate the scene along the grid. So I built tools to rapidly capture and preview. And again, this is not sure how interesting or surprising this is to you. I'm sure you're very familiar with these things, but building a tool chain and allowing people to actually quickly do this using Wizard of Oz and live streaming, you can actually, you could use two phones, one constantly streaming to a user's phone and then doing some manipulation of the objects. So we've looked at Wizard of Oz, and I create one final experience where the goal is to have a butterfly sticking in the air, and I'm gonna show just how we did it. Normally it doesn't need so many explanations. So for you, I'm pretty sure this is straightforward. So we capture a butterfly, but we use physical means to animate this butterfly. And then we produce an AR view of it. And in this case, I don't do the live stream because the phones at the time always ran hot, and it was pre-Kai, and the phones died. I used multiple Pixel phones. They ran too hot. The battery is still an issue if you do constant recording and video at the same time for AR. But we can bring this butterfly, it's static. We can bring it into the room very quickly just using the 360 grid, so we can animate objects around the user. I just think it's fascinating. Maybe a last thing, whenever I present this, people always point out to me, but Michael, this is very static. How do you do interactivity? And I do have a solution. Prototyping gestures. So one thing that I've looked at, and was more or less fun in the HCI community, one popular, there's a lot of research on gesture prototyping and stuff, and one popular paper is the $1 recognizer from Jake Robrock. It was really a $1 simple tool. And so my goal was to create a real $1 recognizer where we actually use crowdsourcing, and we pay maximum $1 to recognize gestures. So we created this human-powered gesture design environment for user interface prototypes. To go to the previous slide. So both of these gestures have now been recorded. What I'm going to do now is actually go into recognition mode. And now we have a worker that just joined the channel. And I want to go to the next slide. So this is immediately sent out to crowd workers, and I can basically advance the slideshow this way. And I will clarify, when I pressed the key, it was when I stopped streaming to an online pre-recorded crowd worker through Mechanical Turk. And essentially for a very short time, they get to see a video stream. They've been pre-trained on some of these tasks. And I was very interested in creating human powered gesture recognizers. And we've looked into what are it's a little bit of maybe a little bit out of context for the rest of the work here, but gesture-based design is very important. It's a very key part of our AR/VR interfaces. So in this thread of work, I've looked at how do we do it without code and creating a worker interface where what is a good way to train them to have them not see too many choices at once and allow them to recognize gestures. And we've done a lot of experiments. And especially when you design and prototype new gestures. So there's a process called elicitation where you have users suggest their own gestures. It's very interesting, but a lot of people do not actually check for gesture ambiguity and conflicts, which is actually a key part of most gesture sets. They're optimized to be so dissimilar that it's easier to recognize each gesture from a relatively small set of template gestures. But if you actually use this human power gesture environment, we thought one cool feature of our system is that we can actually, as we design a gesture set, we can actually build a confusion matrix and actually run the gestures as we're designing them and test them for ambiguity and eliminate, for example, gestures that are recognized that are false positives. And so I thought it was cool. And yeah, I think I'll skip this slide, but there is more about just the gesture part. I've done less of that work recently, but it's been very interesting to me. How do we actually do gesture recognition without code? And using crowds actually makes it easy and fast, can check for conflicts, but the recognition speed is not as fast as a computer trained algorithm is if it's really accurate. You could see that, I mean, we were in many cases below a second, but a response time of just a second is often too high for a production system, but for prototyping, it's fine. I'll show you, so around 7:40 here, so we're about 35 minutes into my presentation. I'll show you 2 more themes of my work, and I haven't seen any questions, so I just keep talking, and we will get to questions later. So on the enabling and studying collaborative experiences, I've done a few projects, and I chose one that I'm going to use now for a little bit more entertainment, and maybe you'll enjoy this. So how would you enable collaboration when it comes to immersive authoring? Many of you have probably used immersive authoring tools. Many of those tools are actually single user. How would you do it? And in my work, I was very fascinated by how complex filmmaking is. And actually, when The Lion King came out, the Lion King remake was done completely in VR. And so we used The Lion King as a little case study. It was also Disney supported research. And I'll show you an example. That was very loud, and I'm sorry about that. Hope you're all good still. So what is Michael showing? I'm showing, we studied The Lion King, and we redid the teaser when it came out. It was one of my more fun projects in the lab. So we had a $25 budget, not $250 million, but 25. And we bought a lot of Play-Doh, and I was using some of my old research tools, and we tried to recreate the teaser. But what we were really interested in, and it's just an aside for the purpose of this talk, is interesting. Look at how collaborative this is actually as a design activity, right? I mean, when I do prototyping in my classes, it's a very collaborative, pre-COVID, let's say, task. Let's look at the result. I always like the soundtrack, but I'm not sure whether you do. So it's the most difficult shot for us. We had to do it in slow-mo, and it turned out quite nice. It's the same, right? There's no difference between the 25 and the $250 million.
Remember,
I mean, actually, Disney liked it a lot when we showed it to them. So it was with Disney Studios, so that's an entity above Pixar, and so maybe they're not as deeply involved with some of this. In any case, what did we just look at? Okay, so it's very interesting from a prototyping perspective. In my opinion, as soon as I add the soundtrack, it's really quite close. But what is very interesting is, how do you actually enable collaboration? Assume that the real world that you just saw is actually a virtual reality. So how do we, this was just immersive authoring, just done physically. How would you do it? And so I was, and a lot of students, I teach students from a broad variety of backgrounds. And when I tell them, you know, creating XR experiences is like making movies. It is funny, not many of us are directors, but we have all seen movies and we all seem to have an understanding of what's involved. So many of us would probably could produce the roles from filmmaking. I mean, you know, director, very important guy, usually a guy, unfortunately, but a person, let's say, a director of photography, not the same thing, right? This is the person actually operating the camera. You have obviously actors. If you have a lot of budget, we can afford Tom Hanks, and otherwise we go for Tom Hiddleston, who I believe is, or Chris Hemsworth for the people out there from Byron Bay. So, and then we have other roles. But if you think about it, XR, okay, director, maybe that's the XR designer developer. Maybe there's a more specific role. Maybe it's the professor. He doesn't actually understand how it's done, but he can direct. Now that is interesting, huh? The director of photography is actually the user. How do you design? It's interesting if you apply these metaphors, think it through. Who are our actors? Okay, the actors could be the XR designer. Many of us are actually animating the objects ourselves, or we work with 3D artists who produce animations for us, or we use motion capture actors, which is essentially most Marvel movies are done that way. And then we have other roles, and it's interesting. So as an XR person, you're supposed to fill all these roles. At least that is what current tools assume. And yes, they provide support maybe with lighting and default lighting and maybe some sound and whatnot. But surprisingly, it is always the same kind of person. There's no real collaboration. So I wanted to study, how do we actually enable collaboration in XR? And so we did The Lion King, and we introduced a director role, and I created a collaborative immersive authoring system where you could actually assume 5 different roles. You could be a light, a camera, you could be an actor, which means you're jumping into a 3D character and animating them. And you have different roles and functionality according to, you have access to different features of the system according to your role. And I show you 3 of the roles: a director, an actor, and a camera. And we're producing an experience here together. Action. So we have Rafiki, which is, it's actually Jane going up Pride Rock, and not exactly like in the final movie. And so, and there were many takes, to be honest, for this one scene. We did 4 takes. And then what does it actually look like from a director's perspective? So this is what actually happened. Obviously, these our actor was moving the monkey. It's probably a little dark here, but the monkey is moving here on the left, slowly making it up the mountain. And the camera is a little confused, but it's an AR camera, so they can move in 3D space, and they have a live preview on the phone, and it's actually interesting. And so I studied multiple things in this project. One about the roles, what kinds of roles do we need in collaborative authoring, and it's immersive, and how do we actually do it in AR and VR? It's called XR Director, and I studied different combinations. And we didn't just do The Lion King, we also recreated physically Beat Saber and an AR arcade plane mobile app, and we studied how we brought all of these existing experiences back to life using people and a director and people in different roles. And so the paper actually then studies what it's actually creating a performance, live performance that you create. And then there are actually 4 different classes of spatial coordination constraints that you have to deal with, spatial coordination aspects you have to deal with. The spatial constraints is obviously you don't have enough space, and I'll show you this one. But just awareness of what's going on in the environment. And if some people are in AR and in VR, it's very different what your awareness is. mappings, especially when you use language to describe to people how to move. And you use, for example, physical world landmarks, but the VR user can't see them. So it is very interesting. And then the resolution in my system, you could actually adjust the resolution to be able to climb up the mountain. You could scale down and up. And if you have AR, VR editors working at different spatial resolutions, it actually also introduces issues. But while we wanted Jane to be able to climb up the mountain, the camera wanted to still be able to do some movements that are not at the miniature scale of the mountain. So it's very interesting. In any case, it's probably a little confusing because I don't go into each aspect, but to me, it's interesting. It's interesting work. It's the role of the different players in the experience, and then how to deal with the spatial constraints. And we did very basic things like scaling and recentering. And you could imagine in the future a more automated system that, depending on the available physical space, it would determine, okay, if you want to do this path, we need to adjust the scale of the VR world accordingly so that you can do it with just this physical movement, but you move in the virtual world, you move essentially further. And so that's what I studied, and I've been very interested in that kind of stuff. So I've gone through a lot of prototyping work, and so I was like, okay, what did I actually learn? What since I didn't go into each paper, and it's a collection of papers I've presented, I was thinking you probably want me to reflect a little bit. So the tools that I've created for rapid prototyping, I can say that I have enabled non-programmers to be able to create at least low fidelity, but many actually refer to those designs that they were able to create as tools as medium fidelity experiences. And that's just using paper and using some of our tools. So without actually spending time in Unity and Unreal. The templates that we used, and I showed the 360 template very briefly, it helped people. It's many people that work with me, and I can do participator design that way because I can involve people that are not as familiar with the tools, but they are familiar with paper and they can understand the template. But using the template correctly is still challenging. And it's often still difficult to imagine, even with our previews and whatnot, what the final AR VR experience looks like. So while I was able to claim that we can reach a certain level of fidelity, there's still a gap. It's not a replacement. And it wasn't actually the goal of my work to replace Unity or Unreal, but maybe to make it easier for people to transition into these tools. And when it comes to working in AR VR and doing things collaboratively, spatial coordination is actually one of the, and it's multifaceted. And I only talked about spatial constraints as one of the facets. And so what I do in the last 5 minutes now is, or maybe it's 8 minutes, since I do have a bit more time. And I do want to show you one more thing. So more recently, so I've been thinking, okay, over the last 5 years in my work, I have enabled people that are not programmers, that are often not trained in design. So for example, instructors in the area of nursing or crisis informatics, enable them to make use of AR and VR. And so these are people that are very critical and they have the right intentions. But how do we actually teach designers how to create better experiences? And is one interesting direction for me, and I'm going to show you an example in that space. And then the other issue that I've always faced, even though we have made a lot of progress in terms of access to AR VR devices, we have various AR VR lab spaces and also computer rooms for students. And we have a rental system and whatnot. It's still an issue to really use it in an inclusive way. There are always people who have experienced VR motion sickness, for example, or discomfort because of glasses and whatnot. So how do we actually make it inclusive? And so I was like, I wanted to ask you, so how would you teach in VR? I showed you this video initially. And so I was very, just gonna replay it one more time.
I want to show you 3D sketching.
So I showed this in the beginning of the presentation. And the tool that I'm going to show you in the next few slides essentially had to leverage a lot of my work over the last few years, from rapid prototyping, immersive authoring, and then also we added live streaming. And so, so we created a system that enables instructors to teach in VR, bring their content into VR, and then live stream to students who don't have access to VR. And so it has two sides, the system that I'm going to show you. I'll show you mostly the instructor side. We grab input from a webcam, we segment out the instructor or not. Sometimes we do, sometimes we just blur. It's computationally still expensive to do human segmentation, although we have the algorithms. Anyway, then you do a live composition of the VR content around the instructor. So for students, it would appear as if the virtual content is really floating around the instructor. From the perspective of a camera, in my system, we can actually have multiple cameras. So you can actually have an entire virtual, multi-virtual camera system, and there's like a film studio a little bit. But it is also designed to be used by just one person. And so if you, I'll show you some examples. And then we have, so we dealt a little bit with calibration, making that easier, enabling instructors to do it. And then there's a live streaming and recording component. And one of the things I want to explore a little bit more in the future is actually be able to record lectures in VR and then live stream, obviously, as video, or produce a recording like the ones I show you. But even then, actually, imagine taking a MOOC and it's actually recorded in VR, and you can actually take the MOOC in VR, but asynchronously. It is definitely one of my next steps in some of my work. So calibration is something that I'm sure you're familiar with. You need to figure out how do we map positions in the physical world to positions in the virtual world. Then we would need to segment the instructor to really have a good experience. We thought a lot about like how to actually do sketching and what's a good way and what are good metaphors. So we have different whiteboards. We have a 2D whiteboard, a clear board, and I'll show you the clear board because it's really an effective way for teaching in VR. And we essentially have, if some of you have become really into live streaming since Zoom and maybe Twitch, and I'm not sure what's a popular platform in Australia. I know some programmers from Australia in StarCraft, they stream on Twitch, and I wanted to create essentially a live streaming and mixed reality capture tool for instructors. So we have various presets. An instructor can choose from existing cameras in the scene. So we set up a few different cameras, virtual cameras, focused on, for example, the whiteboards, or focused on the instructor. There's one position behind this camera here, for example. And then instructors also have tools to actually adjust the cameras if they wanted to. But it's also multi-user, although we haven't really explored that too much in the paper yet. But I am very interested in, for example, Microsoft had a mixed reality days event and they held it in AltSpace, and it was quite cute, quite professionally done, but it used one camera. You could really see how there's a person behind a mouse, maybe a trackpad even. It wasn't very smooth trying to film it so that it can be compressed into 2D. But what if you actually had preset cameras, transitions, cameras on virtual tracks? You could really create interesting blends of virtual and physical experiences. Last thing I'll say is just to tell you a little bit more about my interests. I'm definitely interested in movies and Lion King and all that, but also live streaming. And I found it very interesting how recently the Intel Extreme Masters is like an online, it's actually not an online, it normally would be a physical event. People travel to it and have programmers competing against each other. And it's funny, they sent to all the pro gamers, they sent essentially physical backdrops so that they could all put them up and kind of like better than a green screen. And it's interesting what kinds of efforts we went through in the pandemic to create interesting experiences that look like people were at an event, and then they had the casters and everything using some of the mixed reality capture tools really nicely, even looking at each other and stuff, but it's all fake because it's just, think of it, a person in front of a green screen presenting the weather to you. That's old school. Mixed reality capture allows you to preview live what the end user is actually seeing. And I've talked a lot. I'll show you. We studied 3 different conditions. One was just slides and present. I taught a 3D lecture in my course, and I used Zoom lecture style, quite with annotations and the way I presented here right now to you. And one was a first-person view in VR. This is a typical streamer view at the moment. People put on a VR headset and they show some overlay in some corner of the screen, and then they show first person. And so first person view is interesting sometimes, and our students saw some benefit in seeing things from the perspective of the instructor, for example. It's a little laggy here sometimes, I'm sorry about that. But first person can also be very shaky, and a lot of students actually don't like it, and sometimes even feel a little motion sick just from watching this. And the mixed reality capture, oops, oh, my presentation just died. One sec. I'll show you the last one. The mixed reality capture is, we had different modes. One sec. I put 3 videos in one slide. Maybe that was too much. So mixed reality capture is, this is me in the background. You can see how the virtual controller is actually mapped to my physical hands. And I can start annotating, and I was checking a little bit just to make sure that my students could actually follow along. It's still a research prototype. So I can sketch and talk aloud, but the students can see the VR content really be created around me. The interruptions that I had at the time, the video actually lost frames because I was using our research prototype, recording this, doing live streaming, doing segmentation, doing mixed reality capture, and creating a video while streaming over Zoom. So it was, and it's actually an i9 computer with an RTX 3080 graphics card. So it was really pushing the performance a little bit. But so we compared these conditions, and yeah. So you probably know, what is Michael going to say? Which one was the best, Michael? So it's actually very nuanced. So the slides condition, so we asked students, what's your first choice? And the mixed reality capture condition for the majority of students, these were 11 students, not 12. We wanted 12, but one didn't come. So 11 students, their first choice was mixed reality capture. Just the flexibility and this idea of seeing things around the instructor was actually preferred. And it's a class on 3D design, so you might argue, obviously, that lends itself out to this kind of stuff. The first person view of the VR view of the instructor was also kind of appreciated. And then the slides and maybe novelty effect and wow effect plays a role here as well. Was obviously not as good, was consistently the last choice. But the students also argued that it can be good to see things from the first person instructor point of view. Depends really on the content, what you're sketching out. Obviously, when I was explaining concepts and annotating objects, this clearboard mixed reality capture perspective was very useful. Finally, one thing that was missing in this view, though, is the slides. And so the students really appreciated that our system actually allows to switch between these different modalities, between just looking at 2D slides and have the instructor jump into VR, first person, or jump into mixed reality capture. So while for the purposes of our study, we separated these conditions, the system is designed to support all these conditions and precepts, because I personally believe that there is value in using AR, VR for certain types of activities, but I wouldn't actually hold an entire class like this talk, 60 minutes long in VR. So where to take it from here? So I've been looking at 2 directions. One is really designing good virtual environments for learning. And I'll show you a couple of, I should check with Aladin where we are. I would have a few more examples there if there's interest, but it's early stages in research. We looked at metrics, we looked at space syntax as a way of guiding us through design of virtual environments. And then designing safe user experiences, where as part of COVID-19, we were forced to do some of our studies in participants' homes. So we brought HoloLens devices and iPads with LiDAR. It's actually a work where Shweta was involved as well, to participants' homes. And we showed to participants what kind of data is actually collected at participants' homes if they try out some of our experiences. And while there were initially no concerns, when you show to people that you can essentially take the point cloud data and texture it and essentially reconstruct participants' homes, it does ring some alarm bells. And we did talk to instructors whether they would feel comfortable teaching this way from home, and also exposing essentially their students to potential threats this way. Many instructors just use existing software. So Oculus has this tool, I can teach something to my students, let's just use it. Doesn't sound so appealing. If I say to you, okay, use Mozilla Hubs, Mozilla maybe has a bit more trust, maybe you feel more comfortable. But it really, designing safe user experiences, and we look at it not from a physical harm, but mostly privacy violations perspective recently. Designing safe experiences that way is something that Shweta and I are very excited about, but I didn't have too much to share at this stage yet. It's just some of our most recent work. So in summary, when we do enable, a lot of my work was about enabling more people, essentially creating WordPress, or like if you think about Web 2.0 and all that came about. So if you enable more people, that means more people that are not trained will design AR, VR experiences. I consider the responsibility of AR, VR designers very high. You have complete control over what a user experiences. So that responsibility is very high. How do we actually guide you better in design? And it's not sufficient to just give you a new tool. And so I've become, while I was very excited about my work, I'm also increasingly critical of my own tools. And so I'll stop with the presentation here and pass it back to Valentin.
Thank you, Michael. That's very, very interesting talk and a lot of interesting ideas for prototyping in AR and VR. I like how you experimented with different conditions and seeing how it can be used in teaching, especially good for instructors in AR and VR. This reminds me of some of the work Gunn has done in the authoring tool a long time ago. And I guess Google and maybe some of the previous work has done some authoring tool where they had AR scene created using, I think, was it Google Cardboard, using objects on the cloud, and then you animate the animations and these kind of things. Have you looked into these before and how they evolved, or they are part of the graveyard, do you think, at this stage?
Yeah, so I'm curious what Gunn thinks, who has definitely published in this space way before me. But if you think of, or if you look at some of the latest tools, for example, Adobe Aero or Apple Reality Composer, okay, so they don't use markers anymore. They're markerless, and they would probably argue it's an advantage compared to some of the AR toolkit-based things we've done in the past. But in general, the types of experiences you can prototype that way are still very, very limited. They are immersive authoring, and they still have a cool wow effect on people. But if you want students to really prototype their experience out in these tools, I'm sorry, I think my internet.
Yeah.
Sorry, I should have warned you. This sometimes happens. My computer is like, okay, let's just freeze Michael in the weirdest ways when he makes a face or something. I just said that the tools, even though they have a more modern look, they're actually not more advanced. And I wonder whether you agree, Gunn.
Yeah, Gunn.
Oh, yeah. So thanks for the great talk, by the way, Michael. I think it's great to see a lot of works that you've been doing in prototyping. And I also remember some of the papers I was reviewing them, and it was really impressive, and I was reading them as well. So thanks for the great talk. And I think it's great that a lot of immersive authoring tools are becoming available, and as Michael was presenting, you're very actively using them, especially very interesting you're using for teaching. So I think I should try that for my students as well, probably. One of the things I noticed with your teaching environment was, so the students, correct me if I misunderstood, but so the students are still watching through just 2D video without any VR gears, right?
So for the very specific study presented in the Kai paper, the students were recruited via Zoom. They did not have consistently access to VR. However, our tool, the way it's implemented and the way we tested it, Shweta was also a test user here. We did have students on different kinds of VR devices. Also, they were also part of the room. They're represented as very ugly avatars. Everybody's like a potato of a different color, but it is possible to actually be also part. But in the Kai paper, we did not study. I was more interested in the mixed reality capture and how as instructor in VR, so it's asymmetric to a student who is on a 2D video, whether it actually has any effect on immersion. And so we focused the study that way.
Yeah, that's great. And I think there's a lot of future opportunities that you might look into, actually, the students, remote students actually being able to participate through VR. I think that's a huge opportunity there as well. I was just wondering regarding your study, were there feedback from the students? I understand they preferred the mixed reality clearboard, mixed reality capture clearboard type of video they were watching. But compared to the first person video, I think they might lose quite a bit of depth perception. Like for the first person video, you look at it from different perspectives, so you kind of see the
That's true.
3D depth. But mixed reality capture is just from the fixed viewpoint. So I was wondering if there was any comments regarding that, or was that not a problem much considered?
So I have more thoughts on that than what the students comment on that. So you're right. If the physical and virtual camera, when they're calibrated, they were fixed in our study setup. However, we could also track the physical camera and move the virtual camera accordingly, and that's actually done in a lot of filmmaking techniques, and is and it would actually be another thing to explore. They did not. So they were more concerned about not seeing the slides all the time consistently. And so you could say it comes with additional degrees of freedom, maybe, and maybe also rapid instructor movements in first person. I feel like a little bit, when I put on a VR headset and I know I'm streaming, I jump into this role of more like I'm a director now. So I move like this because my students can then see and it looks smooth. But if you were recording me in a VR headset playing a shooter with my friends, it's more like born movie style, very, very bad for a viewer experience. So the smoothing, I think, is also very interesting. You could actually think about ways of when we stream VR experiences, even in first person, we could also improve that. There actually is a lot of opportunities there too.
Great, thanks for that.
Thank you, Gan. I have a question from Prashant. He's done similar work with bringing also instructor into Zoom. Prashant?
Yeah, thanks. Thanks, Michael. That was a great talk. I was very interested in the XR Studio. Like Aladdin mentioned, for the Sky, we published a XR demo, which is sort of similar in lines of work. So we have a Zoom call, and the instructor can come onto the VR headset and have a virtual camera and move the camera around and showcase what the camera is seeing to the Zoom call participants. That was what we were looking at. I was wondering what the directions, like the future directions of this project would be. Would it be like looking at different kinds of avatar representation, or would be like interactions of how people would move around in such a space? or like what do you have plans for bringing in multiple people to the same space and maybe doing something collaboratively together and streaming it, or like in general what the directions would be?
I think I was just looking at the thing, and actually I remember Mark was telling us about this presentation at Kai. I do think Access Studio and also your work, and there were some other previous papers, they are exploring different ways of making use of VR and embedding it in a way so that you can have the students feel immersed a little bit at least, or like perceive some degrees of freedom in some interesting ways. Ultimately, I do think it is very interesting. One thing I would like to do is actually re-record some of my lectures for the MOOC that I mentioned earlier, and don't compress into 2D, but actually provide a virtual reality recording. So then you could actually, and I've actually listened to my own lectures that I have recorded in VR, and it's funny. So I see my own movement in VR, and okay, I'm a red tomato because I'm the instructor. We color the instructor red. But it's interesting when, and the tool actually, the Access Studio tool also allows you to actually bring back an old recording into a live session. So you can actually replay pre-recorded elements of a lecture. And so I feel like this then becomes a little bit like Inception. You have multiple levels of teaching embedded in AR VR. I think it's a very interesting space to experiment. It's actually very rich. I also think, and actually publishing in this space, and I'm not sure what your experience is. And I mean, GAN has been very early on and very successful, but it's becoming increasingly hard to publish full papers. A lot of people think everything is the same. It's still just immersive authoring. How is this novel? But when I look at just a screenshot that, like from your paper here, figure 1, I think you're laying out a nice set of different modalities. Even just 360 video. A lot of AR VR experts always say 360 is not the same as VR. It's like, come on. But actually, it can be very, very powerful as a tool for instruction. And so I think it's great. I hope you explore this further, and it's a cool prototype.
Was your prototype done in Unity, or was it a different software?
It is actually implemented in Web XR with A-Frame, so on top of 3JS, and it allows us to do very quick updates, obviously. And the biggest issue we have is to get a stable WebRTC live stream between different browsers and different operating systems, because WebRTC, while when it's working, it's like this Kai experience that maybe some of you had. This corridor was implemented with WebRTC, but the protocol is not implemented consistently between different browsers. And so we actually then resorted to Zoom to do a full video and voice chat. But actually we do have the technical implementation. I think my next step would be to really bring it into the MOOC. Now I have a MOOC with 6,000-7,000 learners. I would like to see how many of them would actually access it in VR, and how would they comment. They compare to different versions of a lecture, the mixed reality capture one that I showed you, and a more traditional slides one, and comment on those. And I think it would be very interesting in an asynchronous setting as well, not just a live synchronous. But
really cool work. Thanks for sharing.
Thank you, Prashant. I have one more question, unless someone else has another question. No? So I like, Michael, how you, at the beginning of your talk, you said you want to enable non-designer or non-developers how to quickly prototype AR and VR. There's work in Augmented Human Lab here with Sachit. He's one of the participants here. So he's planning to build a toolkit on Unity to help people he's expert in haptic and cloth tactile. And we want to see if we can bring it to VR developer who don't know a lot about haptics. and how we can enable them to build a haptic experience. Do you have any thoughts based on what you have done so far, like to bring it from expert user to non-expert user, how to go around maybe adding a dimension of the haptic or not just vision based?
I think it is very important also from an accessibility perspective. I do think, so I'm very excited. It comes up in two. I'm not very experienced in haptics, and I would agree with what you said that current toolkits are actually mostly visual. If we have any widget libraries at all they give you is some nicely designed with visual feedback, maybe some audio feedback, but any integration of haptics is very custom. We also don't have any standard devices, and vibration is very limited form of haptics. So in general, I think it is interesting for two reasons. One is on the inclusive side, so designing more accessible experiences. And so a project that I'm very excited about, it hasn't really started yet, but is work here at the University of Michigan on more working with a biomedical engineer who has created a kind of like an implant for people that a visual prosthesis for people that have lost part of their vision. They were soldiers and they got injured in the war, and now they're getting some vision restoration. But we want to guide them by sending kind of like different forms of multi-model feedback to guide them, using AR techniques to guide them in everyday tasks. So essentially using AR techniques, let's say what I mean by that is like the sensing that we often have, and using actuators and vibration to actually encode to participants how they can safely navigate in an environment. That is maybe a bit more advanced than what you asked, but also in general, I think the toolkits that we have right now are very poor when it comes to audio support. Audio is like its own thing, and actually there has been separate research on that, and haptics, and it is so fundamental. It really makes a big difference. If I were to create a future Zoom, and that's something that I really am interested in, the things that we just talked about, live streaming and different visual angles and stuff is interesting, but also using haptics to maybe make some of these things feel or help us get better sensations about the experiences we have in XR, especially in a remote environment, I think is very interesting. Imagine that you can feel what the physical object that you as the instructor have in front of you, but you can allow your students to feel it. Yeah, and I think that's very exciting. But a toolkit, especially targeted at researchers, I think is also could be very powerful research publication in the future.
Sounds good. Thank you very much. Any other questions from the audience? Okay. I will conclude this seminar. Thank you very much, Sam Michael. We really appreciate you sharing your experience with us and answering these questions. Look forward to your visit to New Zealand or Australia in the future.
We'll pick you up on that one, definitely. Thank you very much for having me. Okay.
Bye for now.
Thank you very much. Thank you.
Bye-bye.
Thank you.